today we're going to be talking about how to find the solutions to a quadratic equation. So first we have to talk about what are the solutions. So the solutions are just the x-intercepts of the parabola. So sometimes it can have two x-intercepts like we see here. Sometimes it can only intersect it once, and then other times it intersects it 0 times. But today we're just going to be talking about a few different instances of when it does intersect. So the first equation we're going to look at of how to solve is just x squared plus 5x. Now the first thing we're going to do is we're going to factor this out. So then we're going to be left with, we're going to factor out the x, we're going to be left with x plus 5. So now when we're finding the zeros, the solutions, the x-intercepts, they all mean the same thing. When we're finding the zeros of a quadratic, we have to find values of x that when we substitute in to the equation, they result in a value of y being 0. So when we factor it out, we can take, when we have two factors of a number and that number is 0, we know that one of those numbers is 0 because any number times 0 is always 0. So when we take this equation, we have x times the quantity x plus 5. So if we take the x factor, right, what value of x makes x equal to 0? That's just 0, right? So that means one solution is 0. Now we take the quantity x plus 5. What value of x makes the solution, or makes the equation x plus 5 equal to 0? Well, we can just isolate x, subtract 5 on both sides, and then we're left with x equals negative 5. So the solutions to the quadratic equation x squared plus 5x equals 0 is just 0 and negative 5. So that was solving for the zeros of a quadratic when all we have is ax squared plus bx equals 0. So what if we have ax squared plus c, our constant term, equals 0? How would we solve for that? So let's have the equation x squared plus 25 equals 0. Okay, so now what we do is we factor it out, and we're left with x, quantity x plus 5 times quantity x plus 5. Now that's the same as quantity x plus 5 squared, but for the sake of what we're doing, I'm just going to keep it expanded like that. So, like I mentioned earlier, when we have two numbers that multiply and the product is 0, one of the factors is 0. So, because these factors are the same, we can just take one of them, right? X plus 5. What value of x makes this equal to 0? Makes this factor equal to 0. And so isolate x, we're left with x equals negative 5. So because they can't intersect twice at the same point, like on a graph, that just doesn't work. We only have one x value, one solution, and that is negative 5. And so you might start to see a pattern here. It's always the opposite of this number right here. And that is true, but once we are solving for the zeros of ax squared plus bx plus c, and we actually have a value for a, that will change. It will not just be the opposite of this number here. Okay, now what we're going to do is we're going to practice with ax squared plus bx plus c with the entire standard form quadratic. So we're going to have x squared plus x minus 12. So now when we factor that out, we get x plus 4, x minus 3. And so now, like we've been talking about, only one factor has to equal 0. So we split it up. We take x plus the quantity x plus 4. What value of x makes this factor 0? And so that would be negative 4. Now for this one, it's x minus 3. What value of x makes that equal to 0? Add 3 to both sides, we get x equals 3. So the zeros, the solutions are negative 4 and positive 3. So what you'll notice is the x-intercepts are always the constant term in the linear equation, the opposite of that. But the other thing is that we're missing, because we don't have a coefficient of x here. If it was, for example, if one of the factors was 2x minus 4, if that was one of the factors of a quadratic, it would be 2x minus 4 equals 0. Add 4 to both sides. Then we have 2x equals 4. Divide both sides by 2, right? So what that means is we take the opposite of this number divided by the coefficient of x. So if we were going to write that as an algebraic expression, that would be ax plus b equal to 0. And then we subtract b from both sides. And then we have ax equals negative b. But we have to isolate x, we divide both sides by a, and then we're left with negative b over a. And that finds the zeros of a factor.